Alright, so all these ray diagrams, lenses, all that stuff, we're in physics, so of course we have to do some math. So we have to do calculations with lenses. But the good news is all of this should look very, very, very familiar. Remember our mirror equation? 1 over the focal point is equal to 1 over di plus 1 over do, the image distance and the object distance. Well, guess what? We don't call it the mirror equation anymore. Instead, now we call it the thin lens equation. Ta-da! But look, it's the same equation. How about that? It works best with thin lenses. Once you get thick lenses, things start to get a little warbly. So thick lenses don't work quite so well with this equation, but the idea is the same. So remember our magnification equation when we were dealing with lenses? Magnification is the opposite of the image distance over the object distance, or the height of the image over the height of the object. So you see, nothing has really changed. Actually, there is one thing that has changed. Our DO is still positive. Now when you get into honors, that could change, so let's take that with a grain of salt. Your DI, if it's negative, then it's virtual, so this is the same. If it's positive, then it's real. And this would mean that it's upright. And this would mean that it was inverted. Okay, so far so good. Everything's still the same. Here's where things change. When you have a convex lens, this is convex, the light rays go through and they line up over here, and this is a positive focal point. So the convex lenses have a positive focal point. But here's what's the same, is those are real light rays that are meeting up in that focal point. We have our concave lens. Okay, the light rays come in, but they spread out, and they look like they came back, so they were forced to be there. So that's a negative focal point for a concave lens. But here's the thing, it's the same. If you have to force it to happen, it's negative. If it really happens, then it's positive. Same thing with your image. If you have to force it to happen by doing the little ... back, bringing it back behind the lens, then it's going to be virtual, and it's going to be negative, and it's positive, and it's going to be real. So if they really happen, if they really meet up, if your light rays all meet up down here, then you're going to have a real image, and it's going to be positive. So it doesn't matter whether it's on the left or the right. What matters is, do the light rays really meet up, or did you have to force them to make up? That's what's really going to differentiate between anything being negative and anything being positive. Okay, here's what I want you to do next. You should actually go through with your mirrors and with your lenses now and do a compare and contrast and complete a table similar to this where, okay, what's true about the sign on the object distance for mirrors and lenses, what's true about the image distance for mirrors and lenses, what does it mean, what's the focal point like, positive, negative, and then for concave or convex, and then what type of image is formed. You're going to find that for a concave and convex, they're going to flip. So what was true for a convex mirror is true for a concave lens. But I want you to go through and do this compare and contrast. And that's it. See how easy that was?